Welcome to VW 9.5. Today we're going to start talking about something new called logarithms. And it's kind of an interesting concept. We have to get a couple things memorized first. So log form is defined as this. Log, it's called a base. It's like a little subscript. Then you have b, that equals x. And then there's what's called exponential form. That's a to the x equals b. And these forms are representing the same variables in different visual representations. So what you want to do is note this a is your base, just as this a would be the base. This x is actually the exponent, like this right here is your exponent. And then this piece, the b, I call the result. And right there, that is your result. So the first thing we're going to do is just practice it mechanically, right? So right now you might not understand what we're doing, but that will come in time. We're just going to practice these mechanics. This is log form. This is exponential form. Because the first thing says change each exponential statement to log form. So notice how these all match this. So mechanically, we're just going to practice. Let's say we go log, the base is 1.2. The result is m, and that equals 3. So notice how here's our base, exponent, result, and we're done. This is log form. The next one, you could write log, there's e, that number we learned. The result is 9, and that equals b. And this is log form. Now there is a stipulation on this one. Some people write this, ln 9 equals b. And this might look pretty weird. This is actually called a natural log. And a natural log is essentially a special type of log. Notice how there's no base. The base is assumed to be e. So in calculus, you often use natural logs, and all it means is log with a base of e. So for your notes, you can just write this. Log base e of x is the same thing as natural log x. This is the exact same thing. Now the last one, let's try one more. Log, the base is a, the result is 24, and that equals 4. So pretty straightforward. Okay, I'm going to write some over here. So I want you to try these. 2 to the third equals 8. X to the fifth equals 32. A to the b equals c. I want you to quickly pause the video and just convert those to log form, and then unpause it and play once you're ready. All right, so now the answers. The answers are log 2, base 2 of 8 is 3. Log base x of 32 is 5. Log base a of c equals b. Those are your answers. Okay, now we're going to do the opposite. It gives you a log. And notice how I'm reading it. Log base a of 4 is 5. Log base e of b is negative 3. Log base 3 of 5 is c. So the way to go backwards is start here, because that's your base. Then I just think of it as like a cycle. That's your exponent, and that's your result. So a to the fifth equals 4, just like that. And that's done. This one is e to the negative 3 equals b, right? So start the base here, go there, then go there. You also could have written this as ln b, or natural log b, is equal to negative 3. And the last one, 3 to the c equals 5. And again, the side, I'm going to write this, you try. So here's a couple problems I just want you to write down. Try them on your own. Log base 2, 32,768 equals 15. Log base 1/2 of 8 is negative 3. Natural log 9 equals x. Okay, so pause the video, then unpause once you have the answers. Okay, the answers. 2 to the 15 equals 32,768. 1/2 to the negative 3 is equal to 8. E to the x equals 9. Okay, so now that we have that mechanically, now we can talk about the concept of what a log is. And a lot of people who don't understand logs kind of get stuck on this. So if you ever forget what a log is, come back to this video. Logs ask you a question. So really highlight that. Logs ask you a question. Now the question logs ask you is this. Log base a of b means a to what power equals b. That is like the fundamental piece of understanding a log. So you really want to highlight that. So if you look at this, you just have to figure out what it's asking you. Log base 2 of 16 is asking you 2 to what power would make 16? So this thing must be 4. Now if you really understand this concept, it gets pretty easy because now you think, okay, 3 to what power is 1 over 27? Well, that would be negative 3. So if you're really good at this, you could just do this in your head. Because if I look at this, I could think 2 to what power equals 1? That's 0. So notice how all these answers I'm doing, but really just thinking about what a log is. And this one, 1/2 to what power equals 16? That would be negative 4. Now there is a second method, because some people don't like that method. Method 2 is you actually use x. So this is what some people do. They just write log base 2 of 16 is equal to x. And then they just convert to exponential form. That would be 2 to the x equals 16. And then just solve it. 2 to the x equals 2 to the 4. X must equal 4. And you apply that to all of them. Log base 3 of 1 over 27 equal to x. 3 to the x equals 1 over 27. And notice how it's just an algebraic way to understand what we've been doing. And I can do this for all of them, right? 2 to the x equals, oh, sorry, I should go back. Log base 2 of 1 is x. 2 to the x equals 1. X must be 0. Log base 1/2 of 16 is equal to x. 1/2 to the x equals 16. This is kind of a cool one. 2 to the negative x equals 2 to the 4. So x should be negative 4. So you can do either method, whatever you're more comfortable with. I typically do this one because it's faster, but if you like using x, that is okay.